price of Bitcoin for the next 10 days. So let's get started. We will be importing all the models required. Yahoo Finance, Pandas, Empire. Yahoo Finance is the website that will be accessing the Bitcoin data from. How should we access this? Like this, end is equal to date term now, like the data till today, start is equal to India minus 15, like from today to the past 15 years. And the stock, this is the main part. You have to mention the exact ID for the cryptocurrency, Bitcoin, BTC USD, and then you have to download it using this statement, and then it's downloaded. As you can see, for cross-checking, stock data.head. Yeah, we are getting all the data, and if you see the info of the data, as you can see, there's no null values, so there is no point in handling. Uh, there's no need to handle null values for this, and we'll be actually predicting the closing price of Bitcoin for the next 10 days. The closing price is the price at the end of the day, obviously. And then, as you can see, all the closing prices, and we have plotted the close price of Bitcoin over time, like as it was nothing, like 2014, 15, zero, absolutely. Wish I had bought some, but I didn't know what Bitcoin was at that time, and now you can see it's in $100,000 per coin. Totally regret not buying it. And we will be using moving average. Moving average is nothing but it works well with the frequent. If there's a data that has random highs and lows, it smoothens out. Moving average lies is also called rolling average. It smoothens out the data, and we'll be plotting that as well. See, this is the plot uh, for moving average. This is the data. The blue line is the actual data. The green is the moving average for the past 100 days, and the 365 days moving average is a lot more smoother, as you can see. And then we'll be actually using the LSTM model, long short-term memory, for predicting the prices, because time series data. This is the time series data, Bitcoin. We use the data that changes up until now. It is dependent on time. Doesn't it gets affected by random events in the world, and so to predict this, I think LSTM is a better one, because in a time series data, usually the data is affected, like the past values influence the future ones. So LSTM is the best model because it handles lags, seasonality, and during the long term, like the data that we use for this is a long-term data collected over many years in time. It actually handles these long-term dependencies, and it works well with irregular sequences. And after, so we'll be using LSTM, as I said, and then we're going to be preparing the data, like here. We'll be doing the train test split as well, 90% for training and 10% for testing. And then after we have done all the pre-processing of the data, we will be fitting the training testing data with an epochs of 10. Epochs is nothing but we train the model over the same data over a cycle, like a loop, and the 10 here indicates we've been training the model with the 10 times, like it has looped up, like it has gone through the same sets of data 10 times. If you increase this to like 20 or 30, we can get more accurate results, and we've done that as well. And then this is the prediction that we have done for the past 100 days. As you can see, our model has predicted really well for 10 epochs. If you do it like 20, 30 epochs, it does very well. So let's come to the last part. We're predicting here for the next 10 days. This is the predicted data. We're going to plot it as well. As you can see, it's now at 107. For tomorrow, it will be $107,000. And at the end of the 10th day, $92,474. That's it. The prediction is done. And thank you very much.